Hi everyone, welcome to Paradise Business and Technology College Computer and ICT online class. Our class coordinator is Mr. John Copper, which is me. The course duration is 10 to 15 weeks. Computer and ICT is one of the very important course in our school because we want our students to be knowledgeable and familiar with computers and be competent. Most of all, to be competent on how to use the computer, because computer is one of the important technology that we use in our everyday life and also in our work field. So this course is for all our diploma students, so as trade students who are attending our college. This is a new college, so we are not fully established. That's the reason why most of our courses is conducted online, but as long as there is teaching and learning going on. So for this computer class, the practical part will be done later, but this is the theory part. We will do it online. After the online class, we will do our practical part, which is to get the students in a class, and then we conduct face-to-face class on how to use the computer and how to use the Microsoft Word, how to use the computer in their daily life or in their field. So basically this class is about computer and ICT, information and communication technology. Let's look at the outline of the course. We have 8 chapters in this course. We are planning to spend 2 weeks on each of the chapters, and then the assessment on this side here. Of course, in any learning there must be an assessment. For this online learning, we have an assessment component of it. So this assessment, that quiz and the assignment that is there, it will be done online, and then the student have to submit online, and we give the feedback online. So basically we have 8 chapters here. The first one is understanding the computer, computer organization and architecture, memory and storage system, input devices and output devices, computer code and arithmetic, computer software and operating system, computer network, internet and World Wide Web, and the last chapter is Microsoft Office. Especially in that chapter, the Microsoft Office is a very important chapter because we will teach our students how to use this Microsoft PowerPoint, Excel, spreadsheet, and the Word document. So this is basically the outline of our course here. In the first chapter, these are the objectives that we want to achieve. In this chapter, we will learn how computer receive, store, and process data to generate useful information, the improvements in the function of computer in the last few decades, the 5 generation of computer. Of course, computers have generation from first generation to the 5th generation, which is the AI era. So we're gonna look at these 5 generations. How to classify computers on the basis of their operating principle, application, and their sizes. One of the objectives is to understand the computer system as a combination of hardware, software, data, and people. So computer is made up of hardware and software, and that hardware and software work together to store, process, and okay, this is the topics. These are the topics that we are going to cover by people. Okay, so these are the chapter. The first topic system that we are going to look at the introduction to computer, the use of computers in introduction. So the chapter, computers have a wide application. Then we're gonna computing devices, automated computing devices, generation of computers, how they use the computer. First, second, third, fourth, and 5th generation of computers, and then classification of computers based on operating principle, based on application, and based on size and capability. The computer system is made up of hardware, software, data, and people. We're gonna look at that. And last topic is the computing concept, how the computer takes in information, processes it, and gives out the output. Okay, what is a computer? A computer is an electronic machine that takes in input, which is data, programs, and user responses, process it. The computer takes in an input, which is in the form of data and programs, process it, and produce useful output, which is information. It is often called a data processing system because its main function is to process information efficiently. So basically, computer comes from the base word compute, meaning to get the input, compute or calculate and give the output. So computer comes from the base word compute, or in other words we can say calculate. So basically the operating principle of computer is it takes the input, compute it or process it and gives the output. Before it gives the output, it stores it. So that's where we have computers have memory, so that's where they store the process information. So basically a computer is a electronic machine that takes in input, process it and produce useful output. Example of computers ranges from personal devices like laptops, desktops and smartphones to powerful systems like servers, mainframes and supercomputers. They are versatile machines including tablets, wearable technologies like smartwatches and embedded systems in car or appliances designed to process data and perform specific tasks. So these are some of the examples of computers like tablets, smartphones, computer, laptops, anything that takes an input, processes it and gives out output. These are all computers, but they work on different operating systems. Like the phones are working on Android system, and computers they work on Windows. So that's the difference between a phone and a computer, but otherwise they are all computers. A phone is a computer, a laptop, a desktop is a computer, but they are operating on different operating principles. So these are the examples of computer: desktop computer, laptop, notebook, hybrid, tablet and smartphones. Computers are widely used due to their important characteristics including speed. I think we went back to the first slide. Let's go to the next. Yeah, this one. Okay, evolution of the computer. Okay, evolution is basically it's referring to from computers have evolved from the first computer to second, and then from one form to another. So evolution is basically transforming from one form to another. So computers they have evolution. They have evolution history, or they evolve from one to another, one form to another. So let's look at the evolution of computers. Okay, the evolution of computers begin in ancient times when people used simple methods like fingers, stones, sticks, and rocks to perform basic calculations. These methods were slowly and less accurate, leading to the development of more advanced computing devices. So in the past, they used sticks, stones, they used fingers to do the calculation. So these are earliest form of computation or calculation. So it's also regarded as a form of computer. Okay? Because the computer is a device that takes in input, calculates, compute and gives the output. So these are the earliest form of computation that human beings have resort to. Okay, now let's look at manual computing devices were the first major step. Early tools like the sand table. Sand table is one of the, on the foreign side you will see some of the examples of ancient computing devices like sand table and abacus help in basic arithmetic. Okay, more advanced devices such as Nipus bones, slide rule, Pascal line, and stepped reckoner improve calculation, especially for multiplication and division. So these are basically like ancient calculators or the first calculators human beings have used, and these are all computers as well. And a calculator is also a computer because it takes in input, processes and gives out output. So these are the earliest calculators, and they are also computers that people use. Around the same time, Alan Matheson Turing contributed to computing with the Colossus, the first electronic digital programmable computer. It used vacuum tubes, but was designed for specific tasks only. So Alan Turing invented the third computer, okay, and it's faster than Icons and Babbage's, but then it uses vacuum tubes. So that's the third computer developed by Alan Matheson Turing. Okay, let's look at the next. In 1946, the ENIAC electronic numerical integrator and computer developed by J. Presper Hickett and John Maudsley became the first general-purpose electronic computer. It was very large but much faster than earlier machines and could perform complex calculations. So year after year, people came in and invent new computers from time to time, new devices. So it was a bit faster than the previous one. The previous one was slower, and then the new machines were faster than the previous one. So that's how computer evolved from manual computing device to Babbage to ICANN, and then Turing, and then to these two gentlemen here, John Maudsley and J. Presper Hickett. These two important persons, they also invented some computer later on. Okay, this is one of the invention, the EDVEC electronic discrete variable automatic computer. It was invented in 1949. Also by Hickett and Maudsley introduced the stored program concept using binary numbers to store both data and instruction in memory, an input step toward the important step towards modern computing. Okay, so previously computers don't have memory, but as time goes on, new invention start to have memory. They also decide to put in the memory and all this, so it can store data in the form of binary. And then another early computer, the EDSEC developed by Maurice Wilks, used vacuum tubes and could process about 650 instructions per second. Though it was still relatively slow. Okay, but this computer was invented by this person here. It's faster than other machines that were invented previously. Okay, finally in 1951, the first commercial computer, okay, UNIVAC, was developed by Hickett and Maudsley. It could process both numbers and text and introduced the separation of input or output and processing functions. So this is one of the computers invented in 1951. So we have successive inventions from Babbage up to that point there. Second generation, they use transistor instead of vacuum tubes. First generation, they use vacuum tubes. Second, they use transistor. They are smaller, faster, cheaper, and more reliable than first generation. Introduced for this generation of computer, they introduced assembly language. Example like IBM 1401, IBM 7090. And then the limitation of this generation of computer, they're still expensive. These computers, first and second generation, it's owned by only big organizations and the government departments. Individual and some other small companies, they cannot own this kind of computer because it's very expensive, and because it uses a lot of power, it heats up, so it requires air conditioning system to place these computers in, so the room is always cool, all the time cool for this computer. And then we have limited input and output improvements. Third generation, they use integrated circuits, IC. So first generation, vacuum tube. Second, transistors. Third, integrated circuit. Much smaller, faster, and more efficient. Introduce high-level programming language. Could handle multiple tasks. So that's the only computer. Third generation starts to handle multiple tasks. Limitation, it's still the cost of the computer is still high, and limited storage and required cooling. It's still because of it uses more power and all this, it heats up and all this, so it still requires cooling. So cooling, in order to install aircon and all these things, it's also costly. So it's economic wise, these 3 generation of computers is the cost of running the maintenance and cost of running the computer is very high. At the same time, the price of the computer is very high. So only big companies, government department and organization, they own these computers, 1st generation, 2nd and 3rd generation. 4th generation, that's the time it uses microprocessor. Okay, microprocessor. 1st generation uses vacuum tube, 2nd transistors, 3rd generation use ICs, and 4th generation use microprocessors. Microprocessors are mini processors. So that computer is very fast at the time because the task of processing input information is delegated to microprocessors. So that's when the computer is very fast. So development of personal computer, that's when we have this PC. Personal computers was introduced in the 4th generation. Introduced GUIs. GUI stands for graphics user interface, better storage and networking. This is the time we have introduction of internet and networking. That was introduced in the 4th generation of computer. 4th generation of computer era. Okay, it was very powerful, compact, reliable, and user-friendly. Downside or limitation of this 4th generation of computers: complex chip manufacturing, because it uses microprocessor and IC. We need companies, the manufacturer of these computers need to manufacture complex IC chip and IC processor and all this, and it's still dependent on user instructions. So this computer from 1st generation to 4th generation, it depends on the instruction of the user. If there is no user, then the computer is not useful. The computer has to have a user to use the computer. So now let's look at the 5th generation. 5th generation is when we have, based on ULSI technology. You can check on internet what is ULSI technology. Okay, 5th generation include modern computer, laptops, mobile devices. The features of this computer: very high speed, large storage, multitasking, multimedia. Development of AI was taking place at that time. So we are in the 5th generation era of computer. Parallel processing, meaning it processes a lot of instructions at the same time. We have internet and advanced system put together. And then the limitation of these computers, it's still like full human-like intelligence, even though it's artificial intelligence. It's AI, but it's artificial. They say AI, artificial intelligence. So that means the intelligence of the computer is not up to the human intelligence. That's why they say artificial intelligence. Mr. Killen is talking at the back of me. Okay, now let's look at the classification of computers. Computers can be classified into 3 main categories based on operating principle, application, size, or capability. So these are the classification of computer. We have computers can be classified based on application. Like based on application, we have analog computers, we have digital computers, and hybrid. Hybrid uses both analog and digital systems, so that's why there's a hybrid. Digital, there's ones and zeros. The calculator that you are seeing, the calculator that you are using right now, is a digital computer. Analog, anything that is like anything has a moving arm, anything that has a moving arm, like the watch, that's an analog system. Your calculator, it's a digital computer. Okay, computers are classified based on purpose. We have special purpose computer and general purpose computer. General purpose computer can do general work. Special purpose, designed for a particular work, like the ATM machine or Air Force machine. These are special purpose computer. General purpose, they can do multitask, like our PC and laptop and all this. Okay, based on size, computers can be classified based on size. If it is based on size, we have microcomputer, workstation, mini computer, mainframe computer, and supercomputers. Supercomputers are used by NASA and all these big organizations. These are very high-speed computer and more powerful. Mainframe computers, they are used by like control rooms in the minings and all these, or computers. So computers based on size, Google and YouTube and all these people, they are using all these supercomputers and all this high speed and more powerful. Okay, operating principles. Computers can be classified based on operating principles. The three types of computer based on operating principle. We have analog computers. Analog computers produce continuous data like electrical signal, very fast but less accurate, used in scientific and engineering application. We have digital computers process data in binary form, ones and zero, highly accurate, reliable, and widely used. Example: personal computers. Hybrid computers combine features of analog and digital computers, fast, accurate, and efficient, used in hospital simulations and engineering. So these are the different types of computers based on operating principles. Based on application, computers are classified based on application. We have general purpose computers and we have special purpose computers. General purpose computers, versatile machines that can perform many tasks but may be slower for specific jobs. Special purpose computers designed for a specific task, faster and more efficient but not versatile. So a special purpose computer, we can say ATM machine, Air Force, these are special purpose computer. General purpose, we can say our computer is a general purpose computer. Based on size and capability, we have microcomputers, small, inexpensive computers for individual use, example desktop, laptop, NL devices. Mini computers, medium-sized systems that support multiple users used in small to medium businesses. Mainframe computer, large, powerful systems used by big organizations for processing huge amount of data and supporting many users, like the ones used in banks. Okay, especially in the banks, these are mainframe computers. The one that we use, our laptop, desktop, and all this, is a mini computer. Supercomputer is the fastest and most powerful computers used for complex scientific calculation like weather forecasting and research. So weather people, they have such computer, and NASA, people like NASA, they use organization like NASA, they this kind of computer, supercomputers. And I think Google classification of computer by purpose, we have general purpose and special purpose. We have by size, we have super, mainframe, mini, and microcomputers. So these are the classification of computers based on size and purpose. Okay, let's look at computing concept. Computing concept explain how a computer works through the input to process output cycle. So input process output cycle, IPO cycle. So input is basically what we give to the computer by user. The computer accepts raw data from the user using input devices like keyboard and mouse. And then what computer does is it does processing. The CPU. CPU is like a brain of the computer. Process the data using programs or instruction, or in other words, we can say software, to convert into meaningful information. And then before it gives the output, it stores the data in the computer. So storage comes in. The process data is stored in memory, main memory or external memory. So memories, it's a big topic of its own. Later we'll look at the types of memory. Output, the final information is delivered to the user through output devices such as monitor and printer. So anything that the computer gives the output to, like screen, printer, and all these are output devices. We also have input devices like mouse and keyboard, and we have the CPU, which is the brain of the computer that does the processing. After processing, it stores it in the local disk or in a flash drive or hard disk or whatever, and then gives you the output. So on this side here, you will see the diagram again. Input devices, that's where we use mouse, keyboard, and all these things to give the input to the computer. It's raw data. Once the computer takes that data, it looks for the specific program like the software to process the data in the CPU, and before it gives the data out to the user or output devices, it stores the data in the memory. So that's how basically a computer works. It's a computing cycle. So that's the diagram here. We have input, we have the CPU, central processing unit. That's the brain of the computer. Inside the CPU we have the control unit and the logic unit. So later when we come to the architecture of the computer, we will know the function of control unit and logic unit inside the central processing unit. And then we have the memory and we have the output. So basically user gives the input, and the CPU, which is the brain of the computer, accepts the input, process the input instruction, and store the process information and give the output. So we as a user, we give instruction to the computer. Computer takes our instruction, look for the specific software that will process that information, store it in the memory, and gives us the output. So that's basically how our computer system consists of four main components that work together. The hardware, which is the physical part of the computer, like screen, monitor, hard drive, CPU, all these things, anything, motherboard. Later when we do the practical, we will identify this hardware component. And then we have the software, anything that is inside the computer, like Microsoft Word, photo editor, VLC player, photo viewer, all these are software. And then we have the data. Data are the information that we give to the computer and whatever that is stored in the computer, like pictures or video, whatever, these are data. And then the people, or sometimes they say user. So our computer system is made up of hardware, software, data, and people. These are very important. Without the people, the computer is just sitting there. Without the software, our computer is not a computer. Without the hardware, there is no software, there is no data. So these four things work together. Okay, hardware, physical part of a computer such as keyboard, mouse, CPU, memory, monitor, and printer, responsible for input, processing, storage, and output. CPU is the brain, is the main unit with ALU, performs arithmetic and logical operation, and CU, control units, control and manages all operation. Okay, the software programs and instructions that make the computer work. There are two types of software. We have the application software used by user for specific tasks, example word processing and spreadsheet. System software control hardware and support application, example operating system. So for the hardware, we have basically 5 hardware. We have hardware components. We have motherboard, input, output, monitor, anything that is physical. For the software, it's program and instruction and software. So there are two types of software. We have application software, anything that you install into the computer, and system software, it comes with the computer, like operating system is a system software of a computer. Microsoft Word, photo viewer, or MYOB, AutoCAD, or any software apart from operating system is application software that we install into the computer. So the difference between application software and system software is system software comes with the computer. Application software is a software that we install onto the computer or onto the operating system. Another difference is without application software, the computer still run with system software. So that's the difference. So system software is very important for a computer to function. Without operating system, which is the operating system software, the computer does not function. It's a blank computer. But without application software, the computer still runs. So system software is more important than application software for a computer to run. So you have to differentiate between that. So make sure you understand the difference between application software and system software. Some important terms to remember in this chapter. Computer is an electronic machine that takes in input from the user and stores and processes it to generate the output in the form of useful information to the user. Data, the raw details that need to be processed to generate some useful information. Program, the set of instructions that can be executed by computer in sequential or non-sequential manner. Program, sometimes they say software. Software program means the same thing. Information process data used for the user. CPU, the processor of the computer that is responsible for controlling and executing instructions. CPU stands for Central Processing Unit. Monitor, a screen. The screen of the computer, we don't say screen, we say monitor. A screen which displays the information in the visual form after receiving the video signal from the computer. Transistor, a semiconductor device that is used to increase the power of the incoming signal by preserving the shape of the original signal. So second generation of computers, they use transistors. Microprocessor, an integrated circuit that contains the entire central processing unit of a computer on a single chip. So microprocessor is a reduced it's a small mini processor that is used by computers. So the latest computers, they use a lot of microprocessor, so it's very fast. Unlike in the past, there is only one processor, so that all instruction is executed by one processor, so it makes the computer more slow. But now we have a lot of microprocessors, so the task is delegated, so computers are very fast. Vacuum tubes and electronic vacuum tubes and electronic tube for which all or most of the gas has been removed, permitting electrons to move with low interaction with any remaining gas molecules. So vacuum tube was the major component of first generation of computers. LSI, large scale integration. VLSI, very large scale integration, refers to an IC or technology with many devices on a chip. So these are the components of early generation of computers. VLSI, ultra large scale integration. IC, integrated circuit. IC stands for integrated circuit, the circuit that combines various electronic components such as transistor, resistor, capacitor, etc. onto a single small silicon chip. So ICs, fourth generation of computer, they use ICs. Analog computer, a type of computer which represent data in the form of continuous signal. Digital, a type of computer that store and process data in digital form and is also known as the digital information processing system. So these are the important things, so make sure you take note. A hybrid computer, a combination. A hybrid computer uses both digital and analog system. So a combination of analog computer and digital computer, because it encompasses both the best features of these computers. Microcomputer, a small digital computer that is designed to be used by individual. Supercomputer, very fast type of computer that can perform complex operations at a very high speed. Mainframe computer, a very large computer that is employed by large business organizations for handling major applications such as financial transaction processing application and ERP. So mainframe computers are computers that are used in the banks. Hardware are a group of electronic devices that make up a computer. They are used for performing tasks such as entering the data, processing of data, and then displaying the output to the user. So hardware, anything physical component of the computer is hardware. Software, the programs and instructions that help the computer in carrying out their processing. So when you give the input to the computer, the CPU looks for the software or programs to execute the instructions. So software and hardware, they are stored in the computer in the forms of programs. So when you give instruction, these programs execute our process information and tasks. Instruction. Application software, the program which are designed to perform a specific task. Software we have two types, application and system software. The programs which are designed to perform a specific task for the user, these are application software. The program which are designed to control the different operation of the computer is a system software. So a computer normally comes with the system software. Application software are the software that we install later on. So with or without the application software, the computer still run. But if you don't have a system software, the computer will not run. So a system software is more important than a application software. So example of system software, operating system like Android system for mobile phones and Windows for computers and desktop. Application software like video editor, photo viewer, Microsoft Word, these are all application software. Without this software, a computer that has an operating system will still run. Okay, this brings us to the end of the chapter. That's our first chapter class. Please complete your assignment exercise and submit. We put up a quiz at the end of this. After this, and your assignment as well. So make sure you submit, work on all the assessment and submit on time. And maybe the next video will be our second